Now let's take a look at some of the new nodes that have been added to the function editor and some of the changes to the function editor that we haven't really looked at yet, and also how we can use them to do some pretty cool stuff. So I'm going to show some of these within a procedural terrain first. So go ahead and add in procedural terrain, edit the object, and turn off zero edges, edit the function, delete this seed node, change our wavelength. I'm also going to switch this over to world. Not going to add any extra conversions to the vector. I'm going to go back into the node. One of the new nodes, or a couple of different ones, are now located in the constant nodes. And what we have is a Boolean number and a random constant number. The random constant number will generate a number between a minimum and a maximum range and output that number. And in order to generate the number, you do have to click the reset, which will generate that new number. Since we have it selected, we can see that this number that was just outputted is around 0.75 or so. Click reset. Now we have something around 0.6. So every time you click reset, it's going to generate a number between the minimum and maximum range. So I'm going to go ahead and zoom in, increase the scale of the terrain preview. And what I want to do is use this random constant number to generate a random origin for this fractal node. So the origin is an offset in reverse direction from the offset. An offset node is the exact opposite of the actual vector, and using the origin as the actual position of the node, the starting point on the vector. Now the problem is that there are three different vectors for the origin, or three different numbers part of the vector. We've got the x, y, and the z. Now we could just offset one of the directions or all of them equally and still end up with something kind of cool. But the thing is, if we set up individual random numbers, we have to click reset 3 times, one for the x, one for the y, and one for the z. So instead what we can do is set up something fairly simple that will randomize it a little bit more, and then we can offset the vector. And this is more of a randomization. It allows you to just kind of cycle through a couple of different origins, maybe try to find something that looks a little better or different. So there are other ways we could use it as well. It doesn't have a huge use within the program because of the way you have to use it, or the way you have to modify things to adapt to the randomness. And there's nothing you can really program into the reset button in order to just do it for you. It's kind of just creates a nice generator. It's more for the developers and something fun we can play with. So we need to create a vector. And what we're going to do is right-click, add in a math node, vector operation, and we're going to use the composer 3, which combines 3 different numbers, input 0, 1, and 2, corresponding to x, y, and z. And then the output is a vector. So let's go ahead and increase the maximum range to 100. And since we're going to be basically connecting all 3 of these to the random constant, but modifying them along the way, I am going to add in some other constant nodes, a connectable constant. And I'm going to use a number, and we can connect this number to the random constant. And then I'm going to connect another one. And instead of using copy and paste, I am adding new ones every single time. And the reason for this is I am going to be creating a meta node out of it. And I have noticed issues in the past where if you're using copy and paste, the tool or output isn't recognized. It doesn't always happen, but sometimes it will show up. It's more of an issue when you're inside of a meta node, working on adding in different functions. So creating the meta node should be last for the most part. If you need to make changes, always use the right click to add in new nodes, because all of the other buttons are going to duplicate the last selected node. So now we can connect our inputs to the outputs of the constants and have three separate lines to work with where we can easily connect filters. If I just connected all three of these directly to the random constant, it's going to be very difficult to click on those lines and get some filters in there. Another thing I like to do sometimes is add another set of constant nodes underneath to create straight line connections, and that way that can also make it a little easier to work with that. So I'm going to select what's going to be the x-axis, add in a filter. Actually, I'm going to make sure, and it does, when you hover over it, say x. That's actually new to View 8. In View 7.5 and 7, they were named input 0, 1, and 2. They are now input x, y, and z, so it's a little bit easier to understand how it is they work. So I'm going to add in a filter. And what I'm going to do is just run this through a sine wave, reconnect it if it disconnects you. And before I go ahead and connect this or any of these options or extract them connecting to anything else, I'm going to set up the next filter, and then we're going to be connecting one of these outputs to the other filter. It's just a little bit to randomize the number. You do need to be careful when you're doing this, however, that you don't end up with scales that are too high. So if you need to reduce the max amount, you can. Maybe even bringing it down to 1, but that might not produce a large enough number. The main thing is, View isn't as infinite as we'd like to think it is, and when you reach really, really high vector numbers, up into the range of a couple 100,000, sometimes in the millions, and beyond, the fractals don't work anymore. So that's one thing that can happen. Typically, once they reach a certain amount, they hit rotation values almost, and it's rather interesting what can happen. So what we're going to do for this number is change this over to multiply. We'll have to reconnect it. And then I'm just going to multiply it by a constant number, not a connectable constant, just a constant number. And let's use pi. So let's multiply it by pi, and then we can take the contrast or brightness, whichever is going to give us the most variation, without going too far negative. So let's go ahead and set up the brightness. Okay, so we'll set the contrast to 2, and I'm going to extract brightness and connect this to this multiply output. We can delete that other constant that was created, and we can choose to modify the z as well. Z is probably going to be more important and might require a little bit of a higher output because it will manipulate the terrain the most and really give you a little bit of a better look. So let's select the link, add in a filter, and from the list, let's go ahead and choose gain. And then I'm going to extract the gain and connect that to pi, our constant. and then connect the gain back, since sometimes it can disconnect you. So let's take a look at the outputs. I'm going to go ahead and click the reset button, and now take a look, and we're going to see we've got 0.5 for the X. Probably, if we take a look at the extension, as long as we're over a value of 1, it is going to give us a rounded number. So we can see we're at 151 for the Y, and the Z is 1. So gain looks like it's probably not going to be the best because it does appear to be capped out. We'll take a look at the original number. It is 48.3, and it is going to always give us a value of around 1. So let's not use the gain. Let's go ahead and set up something, just switch it out, and we can use the absolute wave, which will give us a really nice variation. And let's connect the brightness to the same as we did for the X. That should be pretty good. Make sure we have that main input going to the constant. And let's see what the number looks like. And it looks like it is bringing us down to 0. So let's use contrast. And some of these numbers just may not work out all that well. I do want to refrain from using the same ones over and over. Let's go back and set that to power. And we're going to disconnect the other connections and see how that's going to work. It's going to give us a value of 981, which is pretty good. Reset that, make sure it's not going too high. 942. So that should work out pretty well. What I am going to do is add one more filter after the power and use the opposite, which looks like it's way more than it should be, and it's producing an automatic extension that's around 10,000 or so. So I am going to delete that. That's the problem I was talking about before, where you're going to run into these huge numbers, and View does tend to crash when that happens. So I'm just going to leave it at this. This should be definitely good enough. What I can do is delete those constant numbers that I had on top just for sorting. If they're not needed, there's no point in having them in there. Just kind of something to help you while you're building the node. And now we have our vector output we're going to need. So what we can do is select all of these nodes we just created. And actually, to make sure that I don't have any extra outputs, I'm going to connect the origin to this already. And then after highlighting, go up to the top, create meta node, and then we can click edit. And it's going to have our connection to the simple fractal. Let's go ahead and rename this vector. And if you didn't have that connection, you could right click, add output node vector3 output. Also, a little trick, in some areas of the program, certain outputs and inputs are not available, although they can still sometimes be useful. So what you can do to kind of get some of those nodes back in there is create meta nodes with the inputs you want. And if a meta node folder is created in the main or your native content folder for meta nodes, and you add the name of the folder, in this case it would be output, if there isn't one already, and what it'll do is list all the meta nodes in that folder so you can access them directly. That was added in version 7. So if you find that you cannot access an input or output that you want, that you think should work, you can create a meta node by putting that input you want with just a constant node or any other node just to group them together in order to create the meta node, because it does take two. And then you'll be able to access that anywhere in any function. So now what I'm going to do is select this random constant number, which is our main number, and what we can do is extract the parameter for the reset. And added in version 7.5 is the new group function, which allows you to group up individual values or settings that you're extracting into groups and have them separated a little bit better, more organization. So you can give them group names. Let's go ahead and just call this create random, and then we're going to give it a group name of vector and click OK. So you'll also want to save this out. And this is the main metanode folder for the installation directory of the content. Now typically I would put this in the math folder, but because I have a lot of math nodes already in there, I am going to call this, or put it in the turbulence folder, just so that I have a little easier time accessing it, since I don't have any turbulence nodes in this folder. And I'm just going to call it vector random, and then the title is going to be create random vector, and I always like to put in a version number to start with, so let's do version 0.1, so that way if I make modifications, I know which version I'm using. So if I wanted to load that in, I could right click, go to turbulence, and now under meta node we have that create random vector. So we can use that instead of this meta node now. You can delete it and go back to that origin and connect. So now all we need to do is click that create random button, and it's going to generate a random origin for us to use. And those flat areas are just part of the auto fit, so you can check only when saturating and then turn it off if that shows up. So that's kind of a cool little node. It's pretty helpful, and it can be used in a lot of different ways. If you want, you could improve the meta node to create and have a maximum range. That minimum maximum, if you wanted to, you could very easily just extract that, so you could make changes if you wanted it a little higher or lower. If you do want to customize it more, just make sure you're paying attention to that output, checking the extension, making sure that you're not going too far negative or the other way around. I have found that going negative or dividing numbers too high will cause the greatest issues. So we're going to go back now and take a look at that Boolean constant number. Let's go ahead and just delete this for now. And a nice use for the Boolean constant is creating an on and off switch. We'll take a look at it in just a sec. I'm going to move this over to the terrain fractal, something that'll look a little bit better, a little more interesting, and also has the detect rough area output. So I'm going to add in, we're going to go to constant, and what we have is a Boolean number. Now this Boolean number is a value of -1. If we check value, it's a value of 1. So that's all it really is. It goes from a number of -1 to a number of +1. And it may not seem all that useful, but really it's pretty nice. And it goes really well with the new options to the Blender node. So if we add in a blender, we now have that clip ratio 0:1. Now, if you've ever made switches before, or anything to transition, any type of on-off switch you want to create, the way you had to do it before was create a blender, 2 connections, and then you would adjust the ratio moving the slider in order to turn it on or off. And a lot of the tools I've generated work the same way. Pretty much everything in the current version, or the version I'm using right now of Snowflake, and we'll just throw Camera Orbiter in here for a sec, we can see that I have a lot of off-on switches, and that was really going between a blender input 0 or input 1, and then having to go through and change the slider. So there is going to be an update for Snowflake users to change all of those over to this on-off switch we're going to be creating, which is a much better and faster way of working with it. So let's take a look at one use for it. Just a basic on-off switch without any real extra controls. What I'm going to do is connect input 0 to the altitude of the terrain fractal. And now, if we want to work with the rough areas but have a preview, we normally have to disconnect the altitude and then connect the rough areas. Well, let's create a blender instead that we don't have to modify the slider at all. So I'm going to connect input 1 to the rough areas. And let's go ahead and add a little rough area so there's something to work with. So now what we can do is connect our ratio over to this Boolean number. Also making sure that we clip the ratio so that when we have that -1, it's actually going to show up as 0, which is the blend ratio for a blender, 0 to 1. So now we can take the altitude, switch it over, connect it to the blender, and now we have an on-off switch that we can just use a checkbox. So it's a lot easier. And it does simplify the overall node. So what we can do is group these together, or select both of them, and create a meta node, edit, and if we take a look, now when we turn on or check value, it's going to give us an output of 1. So 1 is our input, which is currently connected to the rough areas. So let's just call this on, and then our other input's going to be off. And then we can take this Boolean number, extract it, and call this on. And we'll just name it switch. So right now it's off, so we're showing the altitude, which we have off connected to, and then we can just turn it on. So this is a good way to compare things as well. If we want to make some modifications, or compare it to another type of fractal, let's just add in a very basic noise node, turn the switch on, now we see the noise node, turn it off, we see the terrain fractal. So it's a pretty basic operation, but it does open up a lot of possibilities if you're creating metanodes and complex operations, or just working in the program and you want to have some sort of comparison. And that way you don't have to set up all those different blender nodes. So then you could also save that as a combiner metanode, and I already have a switch I created called on-off. Works the exact same way. So then you can just load that in whenever you want, if you want to create some sort of comparison. And this is really useful for focusing on the rough areas of the terrain. That way you don't have to disconnect. All you need to do is hit that on-off switch, and then you can modify your reference feature size, see what you want to work with, and then you'll be like, okay, that's good to go, and then you can go back to your altitude as the output. So that's pretty nice. So there's also another blender or combiner node that's been added as of version 7.5, and I'm not going to really explain how to use it too much. Not all that familiar with Python at the moment, but if you go to combiner node, add one in, you can now select Python. which is new node added in 7.5. Go ahead and edit the function, and this will give you the ability to run a Python function and use the different return types, double being the number output or input, color, vector2, which is texture coordinate, and then vector3, which is the overall vector, x, y, or z. So that is also available. You can also add extra inputs to it, and then you'd run your function in the top box. So that's a nice addition if you are using Python. And I also want to note that for input nodes, all of the distance input nodes now have a distance unit you can choose from, which changes the output of the number and makes it easier to work with for the scale you're working on. So if we go between kilometers and meters, the number control and the number output in kilometers would be higher than it is in meters. So basically it's just like an internal division based on the unit you want to use. You just want to be careful when you're using display units, because your display unit changes with the application. So if you're designing anything or creating any materials or anything connected to the display unit, and then you modify the display unit, it will modify the surface. Now, this is important for the water, which is now the C object since version 7.5. We're going to go ahead and add that in. And this uses one of the distance nodes. And I am going to go ahead and switch this over to a procedural terrain, because that standard terrain doesn't look very good. I also want to note that I have noticed with the standard terrains that they are more pixelated than usual. So if you need to run a little bit of erosion, diffuse erosion over the top, and that can help smooth it out, either that, and I'll just go ahead and show you really quick. Add in a standard terrain, edit the object, and sometimes they're just a little more square looking than normal. One thing you can do is increase the size or the pixel resolution and then decrease it, and that'll sample it correctly. That's also another thing you can do if you're copying and pasting, copying procedural, pasting it. You can increase the resolution and decrease it in order to enable that sampling mode if it's not registering. If not, go to the Effects tab, run a slight bit of diffuse erosion over it, and that can help smooth it out. So let's take a look at the C object. And let's go ahead and raise that up. And we'll put more of an interesting surface on this terrain. We'll just add some grass to it, and then also add a little bit of sand over the top. Clear out that alpha, and then use a little bit of an environment change just to be along the sea level. And I am going to first go to the main scale, change it to 1, and then I'm going to set under the environment the range of altitude to absolute. And then we can switch over to the C and check the position. See, it's at 42 meters. Go back to the procedural terrain, and our highest point is going to be 42 meters. And then we can adjust that top. And it does look like the absolute mode may be broken again. I'm going to go ahead and bring the slider up halfway for the altitude range at the bottom to see if that'll help correct the top altitude range, because sometimes that's an issue where half of the slider is only being used for the altitude range of the absolute. But this is probably just because the way procedural terrains and their scale is constantly changing. It's probably just an update error. We can purge the memory, see if that works, but it looks like we will need to go by object and just kind of manually adjust that. So it seems to be working by object 0.66. And now we can see that we're going to have that sand material underneath. Now, if you're noticing a difference, especially if you're loading scenes in from a previous version of you, or you're just noticing that the kind of depth you used to be able to get, or coastal foam, just isn't possible anymore, we're going to take a look at something really quick. First, we'll edit the object. We're going to turn off the global wave control. And what you're going to see is that we have the range set to 2 meters for the distance foam along coasts. And that means the foam is going to extend to where the terrain is going below the surface up to 2 meters. Anything below that, it's not going to show the foam. Now, if the scales just don't seem right and aren't really matching up, if you open up the C material and go to the top layer, which is the foam, and edit the function, there is the foam meta node. And if we open that up, one of the controls is the distance to object below, which is what controls the foam along coasts. And it's linked to the typical depth. Now, this value is currently set to 20, and I'm using an internal unit of 0.1. So 20 is actually 2 meters. The problem is, the distance unit is a view unit, which is completely different. So we change that to meters. Click OK, and OK again. And we should be able to adjust this a little bit better, but the display might not be completely accurate. And when we're editing the C, and we go into the object properties, edit object, we take a look at the depth, it still says 2 meters. So this range is always going to say meters regardless. Unless, of course, you change your internal unit, it might change that, changing the display unit. But I'm pretty sure this one's going to stay fixed no matter what. But you might get a little more control over the way this looks, and be able to work with the foam a little better instead of having that view unit. So you may need to change that in the presets in order to get the foam to show up correctly, because that does affect a lot. It also affects other areas of the scene too. So that's just definitely one thing to keep in mind. And going back into the function editor, if you haven't noticed, we now have icons, show and graph, and show large text. Before, those were just checkboxes with some text next to them, so now they're just icons where we can show it in graph or display large text. So now they're just icons rather than text boxes or checkboxes with text.